Good morning. It's a pleasure to be here. In this session, I'm going to introduce you all to forensic toxicology, and I'm also going to introduce you to the general principles of toxicology. At the outset, I'd like to add that cases of poisoning have caused a lot of burden, lot of stress on lives and resources. Since from the beginning of human civilizations, humans have learned it in a hard way since they were not knowing about the potential of different natural substances, plants, etc. They consumed it and they developed toxicity. They lost their lives. So, over the course of our human civilization, humans learned about whether a particular substance is toxic or not, whether a food is toxic or not, whether a plant is toxic or not. And in that process, they have gathered knowledge about different poisonous substances. There are various ancient books which also refers to poisonous substances, poisonous plants, poisonous chemicals, etc. So here in this session, I am going to first give an overview of what I am going to tell. I will begin with definition of toxicology, then I will define forensic toxicology and medical toxicology. Thereafter, I will list out examples of few poisons. Then I will classify the poisons on the basis of their properties and on the basis of their site of action. Toxicology is defined as a branch of science which deals with the study of properties, the mechanism of action, the clinical features, and diagnosis of poisons. So in general, in toxicology, the study focuses on the toxic substances with regard to their properties, their mechanism of action, which is also called the pathophysiology, that is how they act on the human body, where do they act, what is the mechanism of their toxicity, and then it also studies the clinical features and the diagnostic modalities available to come to a conclusion and make a provisional diagnosis about which type of poison or toxic substance was responsible for the toxicity. Now, when you come to the definition of forensic toxicology is a branch of forensic medicine which will deal with the knowledge of toxicology to aid the administration of justice. Now, as I already said, in toxicology, the study focuses on the properties of the poison, the mechanism of action of the toxicity, the clinical features, the diagnostic workup. In forensic toxicology, along with the diagnostic workup, there is also focus on the fatal dose and fatal period. Now, just a quick addition, fatal dose is that amount of dose which is capable of causing disease, damage and death. And fatal period is that period which begins from the time since ingestion of the poison or the toxic substance till clinical manifestations appear and till death occurs. So roughly, fatal period denotes the time since ingestion to time since death. So that is forensic toxicology. In cases of poisoning, whenever there is a death of a patient, the forensic toxicologist examines meticulously for the cause of death. Now, every poison presents a specific challenge to the toxicologist, and toxicologists have to narrow down their diagnosis in order to find out the putative poison / toxic substance. Now let me come to the definition of medical toxicology. It is a field of science which will deal with the identification of the clinical features and it also addresses diagnosis and treatment of cases of poisoning, and additionally suggests guidelines and suggestions to community and to the health policy makers on how to avoid cases of poisoning, what are the do's and don'ts in cases of poisoning. I would add one thing here, that the word management in case of toxicity, when it comes before you, you must quickly understand that management here includes both diagnosis and treatment. The treatment in cases of toxicology can be supportive treatment or it can be specific treatment. In cases of poisonings, largely we do not have much specific treatments available because antidotes are not available in every case of poisoning. So treatment largely tend to be supportive. Now let us come to the definition of poisons. Poisons are substances which can be solid, liquid or gas, and which when introduced into the body, they can cause disease, organ damage and even death. So entry of poison into the body can cause critical features, can cause organ damage and can even lead to death. And poisons can exist in either solid, liquid or gaseous form. Here I'm going to give some examples of poisons, some common examples. Like if we talk about chemical poisons, we have got lead, cyanide, bromine, iodine. If we talk about plant poisons, we have got Apis picatorius, Semicarpus anacardium. If we talk about animal poisons, we have got snake venom, scorpion venom, centipedes. If we talk about gaseous poisons, we have got methane, sulfur dioxide, carbon monoxide and methyl isocyanate. Now coming to the classification of poisons. Here I am going to tell you how the poisons are classified. Poisons are classified based on their properties and based on their site of action. Based on their properties, we can broadly divide poisons into corrosives and irritants. The corrosives can be further subdivided into acids and alkalis, and irritants can be subdivided into inorganic and organic irritants. Acids can be of two types, inorganic acids and organic acids. Examples of inorganic acids: sulfuric acid, nitric acid, hydrochloric acid, which amount for a vast majority of the inorganic acid exposure. Then we have got oxalic acids and carbonic acid, acetic acid, which are examples of organic acids. One very important aspect about inorganic acid and organic acid here I'd like to add is inorganic acids exposure produces more local damage, whereas organic acid exposure produces local damage, but there are also very significant remote damage in the form of damage to very vital organs in the body. Alkalis are again different from acids, and examples of some very important alkalis which are highly corrosive are sodium hydroxide, potassium hydroxide, ammonium carbonate, calcium hydroxide. So like the acids, alkalis are very corrosive in nature. So based on their properties, we have got corrosives and irritants broadly. So after having talked about the corrosives, the acids and alkalis, let me come to the irritants. Now irritants can be non-metallic irritants, metallic irritants and metallic salts. Example of non-metallic irritants are phosphorus, iodine, bromine and chlorine. Examples of metallic irritants are arsenic, mercury, lead, copper, and thallium. Then we have got the metallic salts like zinc chloride, mercury chloride. These are examples of inorganic irritants. Inorganic irritants, which can again be divided into non-metallic, metallic, and the metallic salts. Now, irritants can again be organic in nature. Examples are snake venom, scorpion venom, cantharides venom, bees, and wasp venom. Now, there is another way by which the poisons can be classified, which is on the basis of where they are acting. Here, we will talk today in this session about cardiac poisons, means poisons which act on the heart, and nervous system acting poisons. Let's begin with the poisons which act on the heart, and they are called cardiac poisons. Examples of cardiac poisons are, some prominent cardiac poisons are there such as aconite, digitalis, nicotine, and oleander. They act on the heart, they produce electrical disturbances which are called arrhythmias, dysrhythmias, and that significantly contribute to the clinical manifestations and mortality in cases of cardiac poisons. After cardiac poisons, we come to the poisons which act on the nervous system. Now, there are certain substances which act on the nervous system, and they can either profoundly depress the nervous system or can stimulate the nervous system, such as, and they are called CNS depressants and CNS stimulants. Then other nervous system acting poisons are spinal poisons which act on the spinal cord, and there are peripheral nervous system acting poisons as well. Now let me go to the CNS depressants. CNS depressants are nervous system acting substances. They cause depression of the nervous system. Examples of prominent CNS depressants are opium. Now examples of opium derivatives are morphine, codeine, pethidine. Then we have got barbiturates, examples of which are phenobarbital, pentobarbital. Then we have got benzodiazepines, diazepam, lorazepam, clonazepam. Then we have got the general anesthetics, chloroform, ether, sevoflurane, desflurane, etc. Now all these CNS depressant substances and their derivatives which I have listed out, these are examples of CNS depressions, and they act by depressing the central nervous system. When we come to the CNS stimulants, these are again substances which stimulate the nervous system. Examples are amphetamines, methamphetamines, tricyclic antidepressants, lysergic acid diethylamide, which is LSD. These are the prominent CNS stimulant substances. They activate your CNS, and which produces euphoria, increased restlessness, increased alertness, etc. Now, there are spinal poisons as well, which act on the nervous system. They act on the spinal cord. They mediate their action by action on the inhibitory neurotransmitters. Examples of spinal acting poisons are Strychnos nivis vomica, gelsemium. And then we have peripheral poisons which act on the peripheral nervous system. Examples are conium, curare. Now, before I close this session, I would like to give you a recap to the next session. In the next session, I'm going to talk about respiratory poisons with their examples. I'll give examples of miscellaneous poisons. Then I will give you an idea about the different route of exposure to poisons. And finally, I will talk about the factors which affect the action of the poison in the body, the factors which influences the fate of the poison in the body. So having said that, I conclude this talk. Thank you. If you have any question, kindly feel free to write in the comment section. Thank you.